This lesson is for FST, lesson 10.2 on Pascal's Triangle. Today's lesson is focused on something called Pascal's Triangle. It's a display or an arrangement of combination problems, and it was discovered or arranged by a man named Pascal, so they named it after him. Today's lesson is for students to get comfortable with the triangle and how to maneuver within it and how to recognize some of the patterns that are involved. We'll actually be applying Pascal's triangle to different types of problems later on in the chapter. So think of this lesson as kind of like the day that you learned your ABCs. The reason for why you needed to learn the letters wasn't entirely clear until you started forming words, which turned into sentences, which turned into paragraphs, which turned into novels. So we're just learning our letters today so that we can start to build letters and sentences and paragraphs and novels. One of the ways that the triangle is built is by using combinations, keeping in mind that the n value, when you do a combination, it's n choose r. The n value is going to be the row number that you're on, and you can see the different rows here horizontally. So rows are horizontal in nature, and then the columns are vertical in nature. So if we're looking at this row right here, this is row number 1 actually, and it has 2 columns. And so the next row down has 3 columns in it. It's very important though to keep in mind, students, that when you're counting for finding where your position is within the triangle itself, you should actually start counting with the number 0. So we're going to practice that today when we look at the different triangles. I've listed here in the notes for you several different types of triangles. Keep in mind, however, that they're the same information, just arranged in a little bit different way. Most of the time the triangle is given this way, with just the numbers given. I personally find this particular triangle, especially with just numbers in it and no symbols, I find this one particularly difficult to look at and hard to keep track of where I am. So I usually don't like this type of triangle. I prefer to have some kind of shape surrounding the numbers, like we have here with the boxes, or like we have down here with the hexagons. To me, these are just easier to track visually, but know that your preference may be different from mine, and that's perfectly fine. But that's why I provided a variety of triangles. I don't assume that everyone learns or likes the triangle in the same fashion that I do. There are some patterns that students will need to recognize. Keep in mind that there are lots of patterns in the triangle, and we may or may not learn all of them. In particular, I think it's pretty obvious that the beginning row or the beginning number in each row is always going to be a 1. That's true on all 3 of our triangles, of course. The second number in each row is going to help you determine your row number depending upon the way that you count. I like to consider the second number in to be the row number, and we'll talk more about that in a little bit. In this particular triangle, they've highlighted the triangular numbers, which is the third number in each row. That is not something that students need to know as a characteristic of the triangle itself, but know that there are many other items like this that are possible within the triangle, which we may or may not cover this year. Triangular numbers is not one of the ones that students need to know. So how did the triangle get built? Keep in mind that the triangle is infinitely large, so the triangle does continue on forever. What I've done for you here is given you all the way up to row 7 in 2 of them, and it looks like up to row 5 in that first one. What I've done here is I've listed for you the problems that were designed that have these numbers as their answer. So if you look at the very top of the triangle, the top value in the triangle is the number 1. It comes from calculating 0 choose 0. Or 0 factorial over 0 factorial times 0 factorial, which we know to be the number 1. The next row down is going to be an n value of 1 for both problems, and then we start counting the columns with the number 0. So this is row 1, because this is row 0, row 1, and then the columns go row 0, column 0, column 1. So if you do 1 choose 0, you'll get a 1 here as well, that number there. And if you do 1 choose 1, you also get the number 1, that number here. So now we go down to the next row. Notice that they're all row 2. If we start counting with 0, it's row 0, row 1, row 2. And then the 3 numbers in that row come from column 0, column 1, column 2. So if we were trying to identify this particular position, we'd say that that's in row 2, column 0. The book may refer to that as the third row. So depending upon if you say what row number it is, or if it's the third row down, you'd say row 2 or the third row. And then the book would probably refer to that as the first element, even though we would refer to it as column 0. It's the first element in the row, but it comes from an R value of 0. Other things that students need to know about the property or about the triangle are these 5 properties. These are listed for you in your book. Keep in mind that property number 4 is listed incorrectly in the textbook, so I'll mention that when we get to that particular property. The properties themselves in words I think are very straightforward, but students need to also recognize them in symbol form as well. So that's one of your goals in this lesson, is to understand what these symbols are referring to. If you have n choose 0, that's always going to generate a 1. That's easy to remember because all of the first terms in each row are generated from row number choose 0. And the first number in each row is always going to be the number 1. So that one should be easy to remember. The other one that should also be easy to remember is that when the n and the r are the same number, we say n choose n there. So notice that the last term in each row, the r and the n value are the same as each other, and those are also going to generate the number 1. So that should be an easy property to remember. Second property says the second and next to last terms in each row equal the row number, the number n. So let's look at row 4 here. Row 4 has all the n values of a 4, and if you take 1 less than that, so that would be 4 choose 3, you'd end up with this number here. That's going to be the second to the last term in the row, or the next to last term. If you take 4 choose 1, that's going to be this number here. That's also going to be a 4 because it's the second number in. So when these two are one number apart, or when you're having an R value of 1, you're always going to get your row number back, letter N. Third property down says that each row is symmetric. I think that that's fairly obvious here. If you cut the triangle in half vertically and you fold it on itself, the 3 would line up with the 3, the 4 would line up with the 4, the 5 would line up with the 5, and so on. So indeed it is symmetric. I think that that's an easy property or easy idea to remember. If you apply it now to symbols using combinations, it's not as easy to remember. They're saying here if you have 6 choose 2, then that would be the same as you doing 6 choose 4. The R values here need to add up to the row number. So if you have 6 choose a number, just do 6 minus that number to get the other value. So another illustration there would be 7 choose 3 has to be the same as 7 choose 4, because 4 plus 3 makes the 7. So each row is indeed symmetric, but it's because of the way that the numbers work. Number 4 is one that students need to memorize. The sum of the terms in any row is just 2 to that row number power, 2 to the n. So if you're trying to find the sum of the terms in row 18, you would simply say 2 to the 18 power. Keep in mind that in the textbook there is a typo. The textbook simply says 2 times n here. They've neglected to input the caret symbol. It does say 2 to the n later on in the book, but when they first state the property, it just says 2n, which is incorrect. The number one spot where kids goof up on this particular type of problem is if I ask them to add up the terms in row 18. Many times students come to me at the end of a quiz and they say, I ran out of time, can I have more time? And my answer to them would be, no, you may not. And usually what I find is that they've tried to generate all the terms in row 18 and add them up. Obviously that would take you a long time to do, and so the property is a time saver and one that students need to commit to memory. 2 to the n tells you the sum of the terms in the row. If you needed to find the sum of the terms in row 90, you would simply do 2 to the 90th power. The last property is a pretty easy one. Each element in the triangle is the sum of the two elements nearest it in the preceding row. Let's take a look. If you're trying to generate this term here, it comes from you adding the two terms above it together. So 6 plus 15 is going to generate 21. Same thing here. 5 plus 10 makes the 15. 10 plus 10 makes the 20. So if you were given row 6 and asked to generate row 7, it would be very easy to do. You could just say the first term is going to be a 1, and then the next term is going to be 7, the next term is going to be 21, and you could just keep adding the two previous terms together. Now let's look at that property in symbols. So if you have a property or a row number listed here for n, the r value here and the r value there will be one number apart. So if this is a 7 and this was, say, a 4, this would then be a 5. So these would be one apart from each other. And then this number here for the n would generate the next row up. So now let's put some of these properties into practice in terms of how you're going to handle them on homework questions and quiz questions. If you're asked to figure out the solution to 6 choose 3, according to what we did in lesson 10.1, you could simply calculate that using the definition of combination. So you would do 6 factorial over 3 factorial times 3 factorial. To calculate that, you would just do 6 times 5 and 3 times 2 times 1. 6 times 5 times 4. And when you do that, you'd get the number 20. That is a perfectly legitimate way to answer this question, using your knowledge from 10.1 and the definition of combination. If you want to utilize the triangle, however, you could generate your answer potentially a little bit faster. If I want to generate 6 choose 3 from the triangle, I would go to row 6, column 3, assuming that I am counting from 0. So let's utilize the triangle and remember to count from 0, and let's go to row 6, column 3. So if I go to row 6, that would be this row here. And if I want to find 6 choose 3, I start with 0 and I say 0, 1, 2, 3. The third term in is actually the fourth number in that row, because it's 6 choose 3 is the fourth number in. So I would still get the same answer, but I would have gotten it by looking at the triangle, and no calculation would have been necessary. To find the first 4 terms in row 7, if you had row 6 to work with, you could simply use row 6 to generate those numbers. So that is one option. Use row 6, and you would just simply add the numbers together in the previous 2 above it. Hopefully students know, however, that the first 2 numbers are going to be almost freebies. You know that the first number in the row is going to be a 1, because every row starts with the number 1. And then your row number is going to be the next term. So if it's row 7, the second term will be number 7 as well. The next number generated would be 7 choose what? This one, remember, is 7 choose 0. The next one is 7 choose 1. So the next value would be found by calculating 7 choose 2. And when you do that, you get, if we go back to the triangle, if we had the triangle available, we would just grab the number. If we didn't have the triangle available, we'd actually calculate, similar to what we did with 6 choose 3. So we end up with 15 there. And then the other number we'd need to find is 7 choose 3. And when we do that, I believe we get a 21. Excuse me, a 35. So the first 2 should have been easy. Everyone should have gotten those for sure. And then a common mistake here is for kids to do 7 choose 3 to find the third term and 7 choose 4 to find the fourth term. Make sure the numbers are going in order. Make sure you start counting your rows and your columns with the number 0. So we'd be looking for an answer of 1, 7, 21, and 35 there. The final thing we're going to look at here is using Pascal's triangle to generate the number of outcomes. This is question 2 in the homework. In how many ways can 6 coins be arranged with 2 heads and 4 tails? We have 6 coins and we're arranging them in 2 ways, so we would simply be doing 6 choose 2. I'm going to utilize row 6 to help me get that answer, so I'm going to go back up to my triangle. 6 choose 2 is going to be 0, 1, 2, so the answer there should be 15. Keep in mind that that would be the same answer as you figuring out 6 coins arranged with 4 tails. So 6 choose 4. Hopefully students know that those are going to end up being the same. That's going to also be a 15. So your final answer there is 15, whether you did it for the heads or for the tails.